Hi physical science students, this is a short video about amplitude of a wave. This is for unit 9 TSW number 3. The TSW basically says that you need to be able to say how amplitude is measured and what is the relationship between amplitude and energy of a wave. So here I have a picture for you, a picture of a wave. Oh, this is tricky. Okay, there it is, picture of a wave. And in here I drew from where to where we measure amplitude. Amplitude basically tells you how tall the wave is, and it is measured from the equilibrium position, which is the position where the particles of the medium would be if the wave wasn't traveling through the medium. So this is where normally the particles of the water or of the air would be at the equilibrium position. And then of course when the wave is traveling through the medium, the particles are displaced from this place. And the largest displacement that the particles can undergo, that's called the amplitude of a wave. And amplitude of a wave basically tells you about how energetic the wave is, how much energy the wave is carrying. A wave that's carrying a lot of energy would be tall, nothing new. You would expect tall waves in the ocean to be very strong, to have a lot of energy, whereas small tiny waves don't have as much energy. And the amplitude of a wave depends on several things. Of course, it depends on the original vibration that created the wave. If the original vibration was very, very large, then it would create a very large wave with a lot of energy. Normal tsunamis or regular tsunamis that happen at the sea are caused by earthquakes that shift the ocean bed by about 10 meters. And so the tsunami wave, when it's created, it would be about 10 meters tall. Now the interesting thing is that as these tsunami waves come closer and closer to the shore, they grow in their height, and this is caused by the wave slowing down. So now with the tsunami waves, obviously, where the tsunami happened, where the earthquake happened, the wave would be tall, and as the wave travels through the ocean, as it spreads, as its energy becomes more spread throughout the ocean, its amplitude is falling down, because now it covers more area and still has the same amount of energy as was released during the earthquake. So the waves become smaller and smaller and smaller the further and further away you get from the epicenter of the earthquake, where the earthquake happened. But this small wave, as it comes closer and closer to the shore, starts growing larger and larger and larger, and this is caused by the front of the wave slowing down. So here is kind of a picture of an ocean bed right here, and here is the ocean, and you can see as you're coming closer and closer to the shore, the water gets shallower and shallower, not as deep. And in deep water, water waves travel fast, whereas in shallow water, they travel slower. And here's a relationship that we learned the other day. The speed of the wave is equal to the wavelength times frequency. Okay? And the speed is determined by the properties of the medium that carries it, in this case by water. And in shallow water the speed is small, in deep water the speed is large. So if this value decreases and this value is staying the same, the frequency is given by the vibrations that create the waves. So if this value decreases and this value is staying the same, that means that this value also has to decrease. For example, if this is 10 and this is 5, this would be 2. Okay? So 5 times 2 is 10. Now, if this value right here is staying the same, 2, and this value decreases to 8, that means this value had to change from 5, and it had to become smaller. So in fact, if this is 8 and this is 2, this is now 4. So if the speed decreases, the wavelength decreases, because the frequency is staying the same. And so here on this next picture, come on, okay. So here's the wave when it's traveling in the deep water. It's kind of spread and it's kind of long. And then here, as it's coming closer to the shore, the speed of the wave decreases, and you could say that this part of the wave is kind of pushing the wave forward, because this part right here slowed down and this one is still moving fast, right? It pushes the water higher, and so right here the amplitude becomes larger as the wave comes closer and closer to the shore, but it still carries the same amount of energy as before. It's just that it became shorter and it became shorter. You can see that this half of the wave is still long, whereas this half is already shorter. And because of it shortened and slowed down, the water just rises, and so you get a larger amplitude, which is kind of interesting thing. Now you can explain why the waves become larger as they come closer and closer to the shore.